Hello, in this video we're going to work through this problem here, and we want to find the value of x in the figure below. So to help with explanation, the first thing I'm going to do is I'm going to add some labels here so we can see. So with this problem, I'm interested in this distance x, which is from here to here. So what I'm looking for right now is right angle triangles, because we're dealing with our primary trig ratios that only apply to right triangles. So we see we have a right triangle ABC, and we also have a right triangle ABD. And the triangle ABD is the one that contains the length x. So be careful here and don't get sucked into the temptation to work through using ACD, because it's not a right triangle. So what I notice here is that AB is common to triangle ABC and triangle ABD. So the benefit of that is that since I know one length in ABC, I can use triangle ABC to calculate AB, and then use AB to find x in triangle ABD. So first thing we're going to do is we're going to find AB in triangle ABC. So we see that if we're looking at this angle here, 20 degrees, 10 is the opposite, and length AB is the adjacent. So we're going to use the tan ratio. So we know that tan of 20 degrees is equal to the opposite, which is 10 over length AB. And then we can do some algebraic rearranging here, and we should get 10 over tan of 20 degrees. Now, the temptation at this point is to actually go and write down AB as a decimal value, right? Because we can work out the approximate value there. However, since the length AB is going to be used in our next calculation, I'm going to leave it in this form. And what that does for me is it means that my final answer is going to be more accurate, because I'm avoiding the use of a decimal, which introduces error. So now if we look at triangle ABD, we see we have a 40-degree angle here, and the opposite is x plus 10, and AB is the adjacent. So again, we're going to use tan. So what I know now is that tan of 40 degrees is equal to the opposite, which is 10 plus x, over the length AB. So therefore we can do a substitution here, and I can say tan of 40 degrees is equal to 10 plus x. And this is where I'm actually going to substitute in 10 divided by tan of 20 degrees. So what I'm going to do is I'm going to rearrange this such that I isolate for x. So there's lots of ways to do this algebraically, but one way to do this is we're going to multiply both sides by 10 over tan 20. So I'm going to get 10 over tan 20 degrees times tan of 40 degrees over 1 is equal to 10 plus x over 10 over tan 20 degrees times 10 over tan 20 degrees. Now you might be wondering why I wrote this in gray. The reason is because this is an intermediate step that often I wouldn't write. What happens here is I multiply both sides by 10 over tan 20 degrees. These are going to cancel out. So now what I'm going to get is I'm going to end up with 10 tan of 40 degrees divided by tan of 20 degrees equals 10 plus x. So therefore x is equal to 10 tan 40 degrees divided by tan of 20 degrees minus 10. And so x is approximately equal to, and I come over to my calculator here, and I type this in. And I want to make sure I can type this in one step. It's really important to develop good calculator technique. So 10 times tan of 40, close my brackets, divided by tan of 20, close my bracket. And I know that it's gonna work from left to right here because times and divide are equal order in terms of precedence. And then I'm going to subtract 10, and I get 13.05. And there we go. So now the reality of this problem, just to kind of finish up with a couple thoughts here, is that you could have very well gotten the decimal value here and substituted it in. And I think it's important to understand that and be able to do it that way. However, what's really nice about this problem is it gives you an opportunity to practice your substitution and to work through to a point where you can get as exact an answer as possible. I hope this video helped. As always, please feel free to ask any questions.